All right, now that we started the recording, welcome everyone to JavaScript Meetup in Syracuse of March 2022. We're going to go through the coding challenges from February, and we'll take a look at what Doug has sent here first to see how we went through. So to refresh what the problems were, I've got the answers in here, or my answers as well, but given a list of different attributes between each pair of characters, which is this character diffs file here. Given this file, find all pairs of characters that differ by only one attribute. So that was an easy problem. The medium one was write a function that takes two characters and produces an object of shared attributes. This is very similar to January's one. It's just more or less the opposite of January's one.
Right, to find differences.
This last one was to find differences. This one's create a combined one of similarities. Again, there was a little bit of ambiguity between whether you're given the actual character or the name. So I tried to give an example, or just taking the name. And then the last one was a hard one. And at first, when I introduced it on video or during the meetup last month, it was an even harder problem than this. And it was very vague. It was like, create an algorithm for finding the best way of picking a guess who character from in like the shortest number of steps, essentially. But instead, I gave an example of this is a decision tree where first you categorize by their hair color, then whether or not they're wearing glasses, and whether or not they're wearing a hat. But even still, this is a relatively difficult problem. So
Can you show the actual character list?
Yeah, I did not. In the example that I gave, along with the problem, I didn't include the characters.
The guess who characters?
Oh, the guess who characters. Yeah, sure. I can. Here it is. Guess who characters right here.
Okay, right. So that's what we're sorting.
Yeah. So we're starting with this, and we need to get to this decision tree here.
Hey Caleb, are you able to share the screen on the Zoom?
I'm so sorry. I should have done that a long time ago. Let's go back and share my screen. All right. Sorry about that.
Okay.
Yeah, so this was a guess who characters. The hard challenge was to take these and sort them into these lists where they belong inside this tree. So let's take a look at Doug's approach first. Wow, I guess look at these little tabs for the problems. You know,
Can't do much. But,
well, what was cool is like I was actually planning on creating a website where you could essentially put these problems, like do these problems and like run the test and see if you got it correct or not.
Wow.
And basically, you've basically created that website for us. So maybe we'll just take this and make it into the official website.
Okay. Yeah, you can't enter anything in this. It's all just display.
Right. But it looks pretty cool though. So the first one was, again, we'll review what the question was again. It was given a list of different attributes between each pair of characters, character diffs.json, find all pairs of characters that differ by only one attribute. So that's this one right here. This was actually generated from the last question of January.
Right.
That's where this came
compared
from.
all the characters
Right.
to find the difference between every character and every other character.
Correct. Yeah. So that's where this came from. It wasn't just a made up list of things. In fact, to generate this file, I solved the last problem and then just wrote it to a file. The code for yours here was, I think to get to the code, we do the control U.
Oh no, up at the top.
See the code.
Although it's not color coded.
Okay, no worries. All right, so this is getting the JSON, and then the easy problem is get pairs sharing one attribute. There it is. Okay, character diffs.filter. Looking at the ln, which is the character, looking at its diff and seeing if the length is equal to 1. That's great. The only thing that I did differently was I just pulled out the name of the character. So that's why I'm just mapping over it, or actually I'm pulling out the characters themselves because each each item in the list is characters and their diff. So I'm looking at the diff first, filtering on that, and then I'm pulling out the characters themselves.
Okay.
So if we were to console log my approach here, node 1, 2022. If you're wondering why I have such long file names, it's because I am optimistically thinking that if we were to ever go for more than 2022, this file name will be sorted correctly by year than month. But I also include the name so that you're not having to, I don't know. I could have done without the name, I suppose, but that's why they're so long. So this is just the names that have differ by only one attribute. I believe in yours, it's the same thing, except for you have the diff as well. But if we see here, all of the diffs should only have one attribute, which it does. That's great. I think we had actually talked about this last week about the difference between using a map and filter. So like I think, or last month, did you use a filter last month as well?
Yeah, I think I used filter. I was shaky on map, but I read up on map over the past month and actually read a bit about reduce, but I'm still juggling that one.
Okay.
You know, I could do the simple add everything together, but when it gets to more complex application, I start to lose the thread.
Sure. Okay. We'll see a lot more complicated use case for reduce later today as well. So the medium one was write a function that takes two characters and produces an object of shared attributes. So you have this guess who characters find to get where the name of the character is equal to that character. And then you create a similarities array initialized to an empty array. And then look to see if the two properties, so this syntax is dynamic property accessing, the two properties of the same property on the two characters are the same, and we ignore the name. If they are, then we push that property to the object. So this looks great. Works well as well. Show you what I did. It was a slightly different, again, just using a reduce instead of a for loop. I took my guess who characters find and I just made a little helper function. That's all I did there. I think what you did here in your code was you used, you did property in of the object, which works really well for the for loop. Instead of using that, because I'm using a reduce, I got the keys off of the first character, which basically just gets all their attributes.
Okay.
And then after I have that, I reduce on it. The other trick thing that you could have done is you checked to see if if it's not name, but the neat thing is the names will never be the same.
Right. I was thinking in the event that actually I forgot what we were doing in this one.
Yeah. Well, in last month's one, we did have to check the name.
Right.
Because we had to see if they were different. This time we're seeing if they're the same. And the names will never be the same because if they were the same, this find would have pulled the same character off anyway.
Right.
So, right. Yeah, just a little nuance there. Nothing wrong with it being there. Just it didn't necessarily happen.
Right, but having either assumed that names will never be the same or assume they could be, either way, one of those one of those wouldn't work.
Right. Yeah, that's true. Yeah, if they were the same, there would be no way of telling the two of them apart if this only took the names. So then the other bits that I did here is that I did a reduce on that. And so this is an example of how the reduce works. I did things a little bit differently from how we looked at the January one last time. So last time I did this thing, let's see if I still have it actually. Last time I did this thing where I have the differences and then the attributes, and I check to see if the first attribute is equal to the second attribute, and it's not named. So that's where the not named thing was. Then I have this little ternary expression where I say, if so, then spread the differences into this array and then attach the attribute. All this is saying is like, add this attribute to the list of differences. That's all it means. It's just saying like, take all the differences that I have, spread them out in this array, and then add this other one to it. Otherwise, I just return differences. Now this is, this approach is usually the way you'll see things written when using a reduce, where essentially the concept of it is you don't want to mutate anything. You don't want to change what things are. And so what I've done here is I'm not changing anything. I take the differences, I spread them out, I add an attribute. Otherwise, I just return the whole thing. Turns out though, that it's okay to mutate things sometimes. And that's why I took this different approach here in February. Instead of doing this whole ternary expression, which is kind of difficult to read, I would say, I opened up this block and said, if the first attribute is equal to the second attribute, then I want to I actually did my code wrong. I just realized. No, okay, I'm fine. So what we're doing here is we're actually creating an object rather than creating an array, right? So last time when we were creating an array, we had to like push things into it. Here, all I'm doing is I'm setting a property on an object. So here I'm saying the shared attributes object, I'm going to set the attribute to the attribute value of the first character. I have the second character, they have the same attribute value, but I just picked one of them.
Right.
Otherwise, and then regardless of whether or not I did that or not, I just return the whole thing. So here I'm actually mutating the shared attributes object. I'm adding a property to it if it's a shared attribute. Otherwise, I'm not doing that, but regardless, I'm returning the whole shared attribute. So this is an example of where we're doing a reduce, but we're actually inside of the reduce, mutating the accumulator. And that's safe to do. It's safe to mutate the accumulator. And in fact, it's actually a lot more efficient. This approach creates, every time you use a spread operator, is creating a brand new array. And you're essentially inside of every single loop, creating a whole new array that may have all those elements in it. And so if this was a really large thing, right now we're only dealing with like 3 elements. If this was millions, the difference between this code and this code would be very, very large. Because of all the intermediate things that it's creating. Third problem. All right, so this one was a bit of a beast. All right. Generate a tree from the list of characters where the characters are first split by hair color, then whether they're wearing glasses, then whether they're wearing a hat. So first we take a look at whether or not the array, we look at the character array of guess who characters. We initialize our decision tree. Now you're using a set of all the attributes so that you can see what all the attributes are.
Right, and I learned that set will give you a unique, only similar things will only be included once.
Yeah, that's very true. So that's a often used hack.
Okay.
So if you look to see how to get a unique array, an array of unique elements, you will see this exact hack where you take an array, you spread a new set of the original array, and that will reduce it down to things that are only unique. So that works great. Sample character, you take the first one.
Assuming that they're all the same.
Okay, assuming they're all the same. Prop names, object that get own property names, which you may have researched. There's like, yeah, that works. Get own property names as opposed to keys. If you do keys, you may get the properties of the prototype, but get own property names will only give you the instance properties. Sample character filter, type of sample character P is not equal to Boolean. So this one is about the,
So after the hair color, it's looking for the properties,
got it.
and it has to be a Boolean because we're determining for each one whether it's true or false.
Very cool. And then you're doing a for each for the hair color. Filter on the hair color to get all of them of that hair color. And then you're dynamically setting a key on the decision tree. And you are setting the characters to that hair group that we got from the filter.
Right, yes, and this is where I thought this might be a bit of a hacky approach, because for every property I go through, I attach an array to it of the characters that up to that point satisfy everything that came before and this, and then at each loop we can get rid of the parents array because we no longer need it. But I figured all this creating and deleting arrays might not be the most efficient way to handle this.
Sure. Yeah, makes sense. And then to do that, you then go down the level to do whether or not they have wearing glasses. Do a loop of doing basically the same thing again. And then you're looping down another level to see if they have wearing a hat. But then in that last level, we're checking to see if the last property, make them arrays containing a subset of parent character array.
Because the last item in the decision tree was an array of all the characters that satisfy all of those properties.
Right. Okay. So we're essentially each time we start with a list, and then we take a look at the hair color. We filter out all the same hair color. We then take a look at whether or not they're wearing glasses. We filter out whether or not they have glasses. Then we go down to whether or not they're wearing a hat. Filter that out, and then we attach that array down to this list so that to create the final list. Yeah, so this totally works. Very valid approach. Let's see what this looks like. Hair color black, wearing hat true, wearing glasses true, false. Wearing hat false, wearing glasses true, and then you got top. Good. I have to check to see if mine generated the same tree.
Yeah,
The thing that I did was I just pulled out the names just so it's a little easier to read rather than putting the whole character.
okay.
But it doesn't really matter. I could put the whole character in there as well. So this is what I did for my approach here. I used to reduce, a big massive reduce. The way I thought of this is essentially what I want to do is look at every single character and then kind of like place it where it's supposed to be in this tree. So you can imagine that if I already had this tree kind of set up, I could just be like, okay, where is it supposed to go in this tree? And then just like kind of stick it in there. If that makes sense.
Okay.
So that's kind of what the reduce is doing. It's saying, start with this empty tree and kind of create it as I go and stick them in where they're supposed to go. So the first thing I do is I just have these little helper parameters of the dynamic color keys. So I noticed that you used the backticks to do the prop name and then the actual value. You hard-coded there. I actually did the opposite. Oh, actually, you did that here for hair color. So I did the same thing for hair color, where the value that's in there is dynamic. So I look for the character's hair color, I look for whether they're wearing glasses, and I look for whether they're wearing a hat or not. And then generates that key. Then I need to do some little like preparation of the tree, because the first thing I do is I give it an empty tree. I could have, if I wanted to, given it a pre-populated tree. But I decided instead, what we're going to do is we're going to build the tree as we go. And so the first thing it checks to see is, do we have this particular hair color key in the tree? In other words, let's say the hair color key in this case is hair color black. Does the tree already have a hair color black property? If not, I'm going to create it. And I'm also going to prepare the wearing glasses key and wearing a hat key as well. Then I go another level down. do I already have a wearing glasses key? If I already had that one, do I have a wearing glasses key in the tree hair color key? If so, if not, then I create it, and then I have the wearing hat key as well. And then the last one is another level down, is do I have the wearing hat key in the tree hair color key wearing glasses key? And if not, I set to an empty array. Then all I have to do is, after I've done the preparation for the tree, I know that I can safely access hair color key, wearing glasses key, wearing hat key. And it might be this empty array that I just created. But if it already exists, this will give me an array of other characters that have the same similar characteristics. Then all I do is I set that key to the spread of the similar characters and then the name that I've got. So that was my approach. This only loops over the list of characters once. It doesn't loop over any of the attributes. It doesn't loop over any of, there's no like nested looping. This will run exactly the number of character times. So there's 24 characters. This will only loop 24 times.
Okay.
So I had to ask really such a basic question.
Sure.
Hair, you're checking for the hair color value. Correct me if I'm wrong. You're checking for the hair color value of whatever hair color there is from the hair color property or key. Is that how you have this?
Yes.
Okay.
So
I
when
was just thinking, because I was reading, I'm looking through there, and it's like that's what it looks like you're doing.
yeah, when I'm reducing, are you familiar with a reduce on an array?
Not really.
Okay. Basically all it's doing is like there's an accumulator, which I call tree. And then there's the character. And so it goes through every single element in the list and then kind of like mush mashes it together with your accumulator. And when I mean mush mash is like it can do anything. It could like decide to add them together. It could decide to create a crazy tree out of them.
Like an array map?
It's like a map, except for map can only give you an array of the same length out. Reduce can do anything. It can like take each element and like add them together. It can do a bunch of stuff.
Okay.
So in this case, I'm taking a look at what character I have at the moment. I'm looking at what her hair color is. And then I'm dynamically creating this hair color key. So if you look at the tree that this generates, actually I have it spit out over here as well. Where did I put it? Here it is. It's different from yours because if there was nothing under it, so in your case here we have, there's nobody with hair color black who is wearing a hat.
Right.
Whether or not they're wearing glasses or not. Like there's no one who with black hair wearing a hat and wearing glasses. There's no one with black hair wearing a hat not wearing glasses. So in my case, because that tree never existed in the first place, where'd it go? Here it is. Because I give it an empty array, an empty object, and I'm creating that tree as I go, if that property never exists, it just isn't in the tree. So that's a difference between my approach and your approach there.
Yeah.
We could go through and look to see if it's generated exactly the same one. But I did double check.
Let's just check like one of them. Like hair
Sure,
color
let's
black.
do that. Hair color black, wearing glasses false, wearing hat false. Let's see if that has Alex and Max as well. Black, false, false. So wearing hair color black, wearing hat false, wearing glasses false. Alex and Max, oh, there it is.
Are you each
And then the other one was Tom, and that's the one right here. So yeah, looks like it's generating the same thing.
cool. You're each outputting. It doesn't look like the same format. Is it the same format?
It is not quite.
It's different because I'm including all the empty arrays. So Caleb, if one of those properties had nobody that satisfied it, he didn't go down to the next level. So if there was no hat, he didn't bother including whether or not there were glasses.
Okay.
Because if there's no one in the hat array, there's no one in the hat and glasses.
Right.
So he only included the ones that had people in them. Is that right? Just the one?
Yes, that's correct.
And I,
Whereas I included all of them, like each combination all the way down, even if they are empty.
do you know why he didn't just make a function instead of the reducing? Because the reduce, it's just a function basically, isn't it?
Yeah, so reduce is it's a method on the array object. Just like map is. Map is a method on the array object.
Okay.
You give it a
Having
function.
just learned about it, I can say that like the simplest example that I was able to wrap my head around was just if you have an array of numbers and you want to add them all together.
Yeah.
So first it starts by default with the first element. And if your function is to add together, you add the next element with the accumulated element, which is at this point is just the first one.
The former.
Right.
Yep.
So now you have those two added together is now the accumulator. You go to the next number, add that to the accumulated value, and you keep going. Each time the accumulator grows, and you're just adding. So you're stepping through the array, but you can do all kinds of crazy things like create new arrays or all kinds of stuff.
And that has an advantage over a function or a simple for each loop. It has an advantage to the developer because it's just
Yeah.
better and more. It's just nicer and easier to do that than a for each and a function.
Correct. So
Okay.
so really what it is it's an abstraction over a certain pattern. If you see yourself doing this pattern, you can use a reduce instead. And what that pattern would be is if for whatever reason you have an accumulator set to an initial value,
Uh-huh.
and then you're looping over things and you're running some sort of function that combines what you have with your accumulator.
Mhm.
If you're doing that, if you have code that looks like this, you can make it look like this.
and call the and call that function sort of like as a method or something.
Yes, yeah, it's,
All right,
it's the same
cool.
as map.
I
right?
got it. It's
So I'll give you an example. We'll take a look at the map one. This is a blog post I wrote, so you can. It goes through different uses for reduce as well. And as Doug mentioned, the most common one you'll see is if you want to take a list of numbers and find their sum. This is how you can do it. Just that.
yep.
You just take your accumulator, your elements, and then you add them together, and you start at 0.
And then it's written. And it's done.
And then it's done.
Okay, cool. That's my
You
last.
could do that with a product. You can do that with a min or max. You can check to see if any or all the things booleans in the list. There's a lot of things you could do. You can do recursive functions. You can do function composition. You can do a bunch of aggregates. So can hope if you can take a look at this blog post. I'll put it again in the JavaScript. I put it I think a few weeks ago, but and then map again is similar in the sense like if you have an array and you want to like run a function over it and push those new things to the array, you could write it like this with a for loop,
Mhm.
or you could just do this.
All right.
So again, it's just like a little thing helper that like makes common patterns a little bit easier.
I think I've seen stuff like it. I don't know what language, but that'll be my only basic JavaScript question for today.
Not mine.
Yeah, so it's really cool that I actually put the full characters in there just so it looks a little closer to what you had. But yeah, it looks like it generated the same code.
Awesome.
So in terms of the question that you had about efficiency,
So one thing with mine was I had initially done it with explicitly using the properties wearing a hat and wearing glasses. But I thought, well, let's make it so it'll work with any number of properties that are true or false.
Okay.
Which I'm assuming that also could have been shorter, but that did add a little bit to my logic.
yeah, that's interesting. I think I thought of going down that path as well.
Which I did. The last button on my other page is extra properties. So
Oh, okay.
I did the same thing with.
Cool. Has umbrella, has space type. Like, Cool. That's awesome. Yeah, it'd be interesting. That'd be a fun little exercise to see if I can get my code to handle any number of properties, and regardless of whether or not they're true false. Like, what if they're actually string values?
Oh, right, you want to see, are they the same?
Yeah, that would be an interesting one as well. All right, let's quickly introduce the problems for next month, and then we'll jump into Svelte for a little bit. March, here we are. So we're going to shift gears. We could keep going with this guess who characters. It didn't quite end up where I was expecting, but I think to get to that final leap, I don't know exactly how to break the problem down any further. It would just be like, do the thing, and that thing is really hard to do. So like in terms of how I would have to implement it, it's either this while loop or recursive function. And there's no clean way of implementing it. So instead, we're going to switch to ultimately creating a Sudoku generator. So in other words, creating a Sudoku game that someone else can solve. Now to get there, we probably should actually make a Sudoku solver first, because that will actually kind of help in the process of creating a Sudoku generator. And to get to that point, the first thing we'll do is just a Sudoku checker. Check to see that this grid of numbers that we've got is actually a valid grid.
That it can be solved.
That it doesn't have any duplicate numbers in row, column, or square.
Oh, okay.
Just as simple as that. Because having that will help to be able to check your progress as you're creating the Sudoku solver.
I hate to be that guy, but are you sure?
Am I sure?
Yeah.
It may not. There may be ways of creating a Sudoku solver, and there may be ways of creating a Sudoku generator. They don't care about whether or not they can be solved or whether or not they can be checked.
Not that part. I mean the part of the column and row.
Oh, okay. Could you rephrase the question then?
You said that the first thing we're going to write is something that checks whether a column and row is something.
Has each of the numbers 1 through 9 uniquely. Yeah.
And that's something that is required for checking for a valid Sudoku puzzle. And that's inherent to the nuance of Sudoku.
Yeah. So that's one
Yeah,
of the rules.
every row can only have the numbers, all the digits 0 to 9. Every column, same thing. And
Right.
also that, what is it,
Every block of 3. So if you can kind of imagine, there's like a tic-tac-toe board almost in there. Each one of those squares in the tic-tac-toe board has 9 digits, and those 9 digits have to be unique.
oh, right, no 0.
No 0. No. So 1 through 9. Base 1, starting at 1 index. So that's what we're looking at for March, is just the checker. So the easy problem is just check to see if an array of numbers has the digits 1 through 9 once and only once. If you're given an array, check to see if the array, if they have the numbers 1 through 9. See if you can do it without hard coding the numbers 1 through 9 in there. Second one, check to see if a given 9 by 9 matrix of digits contains the digits 1 through 9 once and only once in each row. So if you can figure out this first one, you're kind of just looping over that to get the second one. The hard one is a step beyond that, where you have to do that for row, column, and the 3 by 3 square corresponding to thirds of the original matrix. So the step from easy to medium is a little bit smaller this time. The step from medium to hard is a little bit larger. Again, easy, medium, and hard are all relative to each other. And easy this month may not be the same easy as last month, and so on and so forth. This will all be in that repository that we'll share at the end of the session as well. Any questions on this before we proceed?
Yeah, Caleb, is that on Slack?
It will be, yes. It will be momentarily at the end of this session. I'll push it up to the repository. The goal, I was supposed to create these tests for February where you could check to see if the code that you wrote actually performed what's required. I will see if I can get that to that in March instead. I was not able to get to it in February.
I do have a question. So the thing that we're checking is a 9x9 grid with some numbers filled in. Or
All the numbers.
all the numbers filled in. Okay.
Yes. Correct. I can give you some grids along with this problem as well, so that you can check them.
Okay.
So I'll put a few grids in there that you can verify. The next month will actually be to generate those grids. So after we have generated those grids, you can go back and use this to check to see if the grids you generated are valid solutions. I thought of doing the generator first, but I figured this is actually a little bit easier. Start with this. All right, let's dive into Svelte now. I was going to do Remix this week, but we're going to share that or save that for next month, I think, just because it's a lot of mental overhead to get to that. Let's take a look at what Svelte says about itself in the docs here. It says cybernetically enhanced web apps. Of the frameworks out there, you've got, of course, Angular, React, Vue up on top. And then Svelte was this kind of like fourth one that gained like a little bit of attention. The developers behind it are very active in the community. I think they're even involved in cross framework products as well. But it's got a very niche culture to it. Write less code, it says, no virtual DOM and truly reactive. So Angular, React, and Vue all use something called a virtual DOM. What that means is they're essentially keeping a copy of the state of the app in memory, and they're doing all this operations to diff it, to take a look at the differences when your state changes, and only make certain operations on it, and then re-render that DOM in the browser. That virtual DOM in memory has obviously a memory overhead, and it produces websites that in many cases are a lot larger than they need to be. So a lot of the web development world is starting to reconsider whether or not having these virtual DOM things is a good idea or not. And so people are going one of two ways. They're either pre-rendering their site on the server so that when it gets loaded in the browser, there isn't as much of a virtual DOM. There's probably still some of it, but not as much. Or can you get away with not having any virtual DOM? Can you use a framework that doesn't require it at all, like Svelte? Or can you completely make it a static site? So that's kind of the approaches that people are using to get there. Svelte is a radical new approach to building user interfaces, whereas traditional frameworks like React and Vue do the bulk of the work in the browser. Svelte shifts that work into the compile step that happens when you build your app. So you can actually run React and Vue without a compile step. You can just open it up in a browser and run it directly in a browser. You can put them in blocks in WordPress. You can use React and Vue in a block in WordPress. But you wouldn't be able to use Svelte. You could use the output after Svelte has been compiled, perhaps, but you couldn't use what Svelte is, I suppose. And technically, you wouldn't be able to use JSX in a code block, but you could use like the raw React render methods. So Svelte actually has a pretty good tutorial that we'll go through here to kind of get a good idea of how to get started. So here we have something that just looks like plain HTML, but you can notice that it has this .svelte extension. Take a look. This is very similar to the solid.js one that we looked at a couple of months ago. So a component is just something that renders some static markup that isn't very interesting. Let's add some data. So let's put the script tag in here. And let's replace this world with a thing that references that data. So now I can change this out and say, hello, Syracuse, which I completely misspelled.
Syracuse.
So the data that's inside of here now is being used to dynamically change this template. This is very similar to in Vue. They have this thing where they have a scripts tag, a templates tag, and a style tag. And that's a .vue extension. Vue does a similar thing where they take your script and they kind of smash it together with your template, and they smash it together with your style and just kind of like crunch it all together in one component. Svelte is doing the same thing, except it doesn't have this top level template thing. Anything that's not in your script tag is a template. Let's take a look at something else here. Our image is missing a source. Let's add one. Okay. You can pull the source from the data. And we just got Rick Bold.
Why? Why did that come up just now?
Well, because we just added the source attribute and
Okay.
it pulled the image. A perfect opportunity to put that in there. So they were saying that you can have some shorthand properties as well, though. Usually we put an alt tag. It's a good idea to put alt tags on images. They're saying if you have something where the attribute is just names the same thing, you don't need to put the attribute. You can just do this. And then so let's actually look back at our Hello World guy. Well, actually, that's not a good example. Let's do an input here, where the value is supposed to be some text. Let's remove. So now we've got our little input here, and the value is ASDF. Let's now pull that value from our data. And so now instead of using that string, we could just say value here. So now if I actually type the value in here, it changes in here. It doesn't go both ways though, because it's just code. But you can see that the value is dynamically being pulled in from whatever is in here. But the shorthand is if this thing right here is the same as that thing right there, don't need to put it on there. So this would work the same. Input. Here it is. Let's take a look what else we have. All right, so I kind of lied when I said anything that's not inside the style is, sorry, the script is a template. Style is not. Style is another one of those things where it is scoped to this paragraph guy. We will see a good example of what it means for this to be scoped a little later on when we get to nested components. Basically what it means is the styles that we applied only apply to this thing here. If you have another component, they don't apply to that component as well.
What can you tell me? Does that mean if you have a second paragraph element that is above it or is below the script style tag? Or?
No, so it still applies to everything in this current template.
Okay.
But if you were to have a parent element or a child element, it doesn't apply to that.
Okay.
Yeah, it's hard to see here what that really means. Hopefully we'll get to a nested thing here. Yeah, here we are. This is a good example of it. So we're going to import a nested thing. And you can see this is a nested one right here, where it just says this is another paragraph. Then we're going to just call this nested one, which is very similar to how JSX looks. You know, it looks like you're writing HTML, right? Where you're just kind of referencing this nested element. So this guy right here is being rendered in here. Now, both of these are paragraphs. You see, this is a paragraph here, and this is a paragraph here. But this is what it means for that style to be scoped. This stuff is not being applied to this paragraph. Even though I told it that all paragraphs would look like this, it only applied it to this paragraph and none of its parents and none of its children. We could even be more explicit and say, I want this to be everything. and it still doesn't apply it to the next thing down. So that's the benefit of scope styling. Usually when you're doing CSS, you have, because it's cascading, right? Whenever you style something, it affects all of its children in particular because of inheritance. But also if you did something as generic as just saying P tag, it will style all paragraphs on the page if you're not careful, depending on the ordering of when they're defined.
Is it actually a sibling, not a child or parent?
So yeah, technically that was a sibling. I guess what I mean by nested is that the definition of the components doesn't live within the same scope. It's a lower scope definition.
Paragraph is a child of the nested tag that you used.
That's right. So ordinarily strings are considered as plain text, meaning that characters like these two characters have no special meaning. But sometimes you need to render HTML directly into components. So occasionally you'll get this thing where you want this HTML to actually be rendered. React has a similar sort of thing where it doesn't allow you to do that, but it uses something else instead called dangerously set inner HTML. It's literally called that because they're trying to discourage you from doing it. Generally, like allowing people to use a string to render HTML is a bad idea because it's a great source of cross-site scripting, essentially. Allowing the user to fake make your website look like how it's not supposed to look, essentially. But Svelte makes it really easy to do that with just add HTML on top of the string, if you ever had to. All right. So this tutorial is designed to get you familiar with the process, but at some point you want to start writing components in the comfort of your own text editor. So this is telling you how to go about and do that. Once you get your project set up, using Svelte components is easy. Compiler turns each component into a regular JavaScript class. Cool. Does this have any more? It does. Reactivity and assignments. So here's our classic counter problem that you'll see in almost every single one of these frameworks. You have a button that let's make it so that whenever we click this button, this count increases. So we have a couple things already created for us. We have a count that's set to 0, and then we have an increment count. So all we have to do in the increment count is increment the count. Plus equals, and then all we have to do on the button is say when we click the button, we want to call our increment count function. And then we don't need to actually call it. So here we are.
I want to call that a loaded arrow function.
A loaded arrow function.
Yeah, it's got the curly braces between the arrow, like in the middle of the arrow function, in a sense.
Oh, this one right here?
Yeah.
Well, actually what you're doing is you're setting an attribute to a function.
Okay.
And it's not really an attribute. Technically, like this is not real HTML. There's no such thing as on click. This is a stealth thing on top of it. We can go ahead and create another button here that we say is going to reset the count. We need to define that function. And just say count is equal to 0. And let's change the text to reset. So we can click this a few times, reset it, it's back to 0. Let's see if you can use arrow functions instead here, just out of curiosity. It may not work because of, oh, yeah. It does work, okay. So you can use arrow functions instead of named functions here, if you want to. let's see if we can get to templating real quick. I know we're running a little late today, but the templating I think will kind of solidify a little bit more here. So automatically updates the DOM when your component state changes. Often some parts of the component state can be computed from other parts. So this is in Vue, there's something called computed properties. Angular has something similar as well called like these getters on things. React doesn't have anything like that because if you want to do that, just use JavaScript. But you can use a React declaration here to say, if I want to keep track of whenever the count changes, I want to keep a version of it that's the doubled version of it. So you can do that. And instead of, we'll add this little paragraph here where the doubled version of what we clicked on is inside of a p tag here. So this double guy is automatically being recalculated anytime count changes.
And what is that? Is that a dollar sign in the beginning?
That's a dollar sign, yeah. Let me make this a little larger.
And what is it?
That's a special Svelte syntax, which is just saying, mark this thing as something that should be reactive.
Okay.
And it automatically knows to look for the stuff
Count
in here.
changes, double changes.
Yeah, that's right.
Is it essentially a declared function?
No, again, it's a little, what's inside the script tag is almost JavaScript, but it's not JavaScript anymore because like technically it's got this other stuff. Like this is not valid JavaScript syntax.
Right.
So another thing that we could do, I wonder if they have two-way binding. Let's see if we get to two-way binding. No, maybe not. Maybe we can go back real quick. Let's take a look at this guy. If we could make this this computed thing depend on multiple things. So let's say we had let second equal 0, and we'll let first equal 0 there. And we'll just copy this guy. And instead of it being count, we'll do first and second. We don't really need the extra special templating here. We'll do handle click, but instead we'll actually pass it a function of the parameter that we want. Actually, I don't know if that'll work. Let's give it a try. This is a little experiment to see if it works. Let's say that we want to take the value and we want to increment it. Does that work? Unexpected token at line number 10. Okay, let's get rid of this computed guy first. Nope, does not work. Okay, so these functions, they actually depend on mutating these values, right? So I tried to take this value and just simply increment it, but it needs to know what to increment. It needs to know to change this first value, which I'm not telling it. I don't know if there is a way to tell it to do that, but let's, for now, just call this one inc first, and the second one inc second. We can get rid of the value. And this one will just actually increment the first one. This one will increment the second one. And in here, we'll just call this guy inc first, and this one inc second. And then we'll just add this last little paragraph in here, which will include the sum. And then we'll say that the sum is equal to the first plus the second. So that's 4. 4 plus 6 is 10. So this reactive thing can be dependent on more than one thing. It's being recalculated whenever first changes and whenever second changes.
Mm-hmm.
Cool. Let's see if we can get a little further here. We're not really limited to declaring reactive values. We can also run arbitrary statements reactively. For example, we can log the value of count whenever it changes. Okay, So they're saying we can actually reactively run side effects as well. We can say console.log, and for now we'll just put the count in there. So whenever we click on this, can I make this a little higher? Here it is. Whenever we click on it, this console is putting that thing inside of, putting that value inside the list there. You can also do alerts. You can do more than one thing. They're saying that if you want to do more than one thing, you actually have to open it up in a block.
So while Svelte is not JavaScript, can you put any legal JavaScript in the script?
Good question. I don't know. I think you can, but things may not work exactly as you expected. Like we tried that thing where we just took the value of the handle click and we tried incrementing it. And what that function would do is like it produces a new value. Actually, what we could do is just say count is equal to handle click. Oh, okay. No, that wouldn't work. Count. Nope, that doesn't work. But the key thing is that you just kind of have
Didn't
to
return anything. You have to return from function for that to work.
good point. Let's give that a try. Is not a type object. Okay. Yeah, I'm not entirely sure. Turn. Yeah, that wouldn't work either. So you can use any JavaScript in here. It's just if you want it to do the Svelte stuff, if you want it to be reactive to certain parameters, you've got to do certain things the Svelte way, I suppose. It is, when I first came across Svelte, actually, I didn't pay too much attention to it because in React, everything is JavaScript. You don't have any weird, funny syntax besides JSX. It really is just JavaScript. Svelte is this like kind of weird JavaScript-ish thing, where you've got syntax that isn't JavaScript, right? Because Svelte's reactivity is triggered by assignments using array methods like push and splice doesn't automatically cause updates. So this is a good example of where JavaScript doesn't quite work as expected, right? So when we are adding a number to here, it's not working at the moment because when we say add number, it's trying to push a new number on there, but that doesn't work. So we actually have to explicitly tell Svelte that after I've pushed it, reset this numbers to that numbers. So now that I can actually push stuff to it.
That's a little confusing.
It is. So what they're saying here is that the only time Svelte reacts to things is when it sees a equal sign, when it sees this thing that I'm supposed to track is reassigned to a new value. And mutating it using a push doesn't reassign it.
So the numbers on that first line of the function, is that a new numbers variable in the new scope, or is that the same numbers that's above?
This is the same numbers as above. Perhaps a better way of looking at this
So is that push statement doing nothing?
it is actually doing something.
Okay, that's what I thought.
It is mutating numbers.
Okay,
But then what we're doing is reassigning numbers to the mutated numbers.
so is it when you say mutating numbers, I'm assuming it's the original numbers is
Yeah.
changing.
It is. The original numbers is changing, but ironically, Svelte doesn't know that.
Okay, but if you somewhere else referred to that numbers, it would show up the mutated version.
Correct.
Okay,
Yes.
so send numbers to numbers.
So if
is
you were
just saying,
to,
wake up.
that's a good question there. So let's say we were to, every time we click on this, we didn't do reassignment, but we did log it. So let's see what we have in here. It is actually increasing the array, but
Okay.
Svelte doesn't know that. So it only knows that when you tell it, hey, I'm going to reassign this thing that you're tracking to a new value. And once you've done that, it's reassigning it to the already muted numbers. It's a little confusing. Truthfully, that's one of the things that didn't hit me in JavaScript until way later than it should have. But the difference between like assignment and mutation, like the ability to just take a value and change what it is versus taking a variable and changing the value assigned to it,
Okay.
is a little bit confusing to wrap your mind around. I'm going to skip ahead just to see if we can get a little bit of idea of what templating looks like, and then we can kind of call it a night. I know we're running a little bit here. This is talking about props. Props is very similar to how we can pass things down in React through props, or in Vue as well. But let's see if we can get to, you can use a spread operator on props as well. There we are. So here's templating. HTML doesn't have a way of expressing logic. So Svelte introduces logic into your templating, essentially. To conditionally render some markup, we wrap it in an if block. So if we want to show the login button when you're logged in, or logged out rather, and the login button when you're logged out, you just wrap it in an if block, and then you wrap this one in the if block as well. Presumably there's an else part of it, but they're just introducing this first. But this is conditionally rendering that stuff. So this is where it starts to deviate quite a bit from what you're familiar with in HTML and JavaScript. There was already these little nuances that we saw there, but now they've added this whole like templating language on top of it. This is a little bit of a debate, I suppose, in the whole JavaScript framework ecosystem, whether or not templating is a good idea or not. And truthfully, you can't really get away from it. If you want to, I think React does a really good job of not doing templating. When you see JSX, it looks like templating. But really what it is like, it's a syntax on top of JavaScript. And you could do the same thing without using JSX. You could just use regular JavaScript. If else, you can use maps in React. You can use for loops. You can use reduces in React if you want to. But you can't in Svelte. In Svelte, if you want to do any logic, you got to do it the Svelte way using templating. So I think that's where we're going to leave it off for now. I did want to just kind of talk about quickly the benefits of using Svelte. Like, why would you use this as opposed to something else? They don't seem to have the performance comparison here, but let's see if we can Svelte versus say React in Vue. I don't know if they have a good performance metric somewhere. I'm surprised they don't. But essentially, Svelte is like wicked fast. Compared to using Vue or React or Angular, those compared to just not using that framework, like if you were to write in vanilla JavaScript, they're almost 1.5 times as slow if you were to use one of those frameworks. Svelte's more like 1.1. It adds very little overhead on top of just running raw JavaScript. For reference, when we looked at Solid 2 months ago, that's even lower. I think Solid beats up Svelte by a bit. So these new frameworks are coming onto the scene that they're not quite as popular yet. Svelte's been around for a long time though, but they're not quite as popular, but there's a lot going for them because they're a lot lighter weight than some of these larger things.
And you said also it's less memory because it's not storing a virtual DOM.
Correct. Yeah. So what's going on behind the scenes is essentially Svelte is doing documents.getElementById It's doing like append node. It's doing all this raw JavaScript DOM manipulation stuff
Okay,
without having a different DOM stored in memory.
and does it only change, because my understanding of having the virtual DOM is like with React, it can keep track of, it knows only what's changed, and then it only changes that in the actual DOM.
Correct. Yeah.
So is Svelte without a virtual DOM keeping track of what's changed still? I guess it surprises me that if it's making if it's actually manipulating the DOM directly,
Yeah,
that it's still so much faster.
yeah, that's a good question. So I believe we didn't get far enough to see that, but I believe there's probably some nuance there. If you want, like, for example, the fact that it didn't see the push and react to it, it needed that assignment. There's probably some other nuances where, let's say you have this 1,000,000 item array and you change one item in there. And then you reassign that entire array back to that thing because you have to tell Svelte that this changed. Is Svelte smart enough to just find that one change and just change that one DOM element? My guess is probably they have some smarts in the hood, but there may be some nuance to how you have to tell it to do that. Similar to Solid.js a couple months ago, you don't have to explicitly tell it, but they have these little helper template functions, like a for helper and like an if helper that's under the hood knows to do that different for you. So you can still get the benefit of diffing and making sure that only things that changed re-render, but you may have to do things a slightly different way than normal to make sure that diffing happens.
Okay, makes sense.
Cool. Yeah, so if you want to check out Svelte, that tutorial that we went through, I think does a pretty good job. We can keep going through that on your own time. And yeah, we can take another look at it in the future if you're interested. But for now, we're going to call it a night. I'll stop the recording. Thanks everyone for coming, and looking forward to seeing you next month.
Thank you.
I'm gonna throw urgent out.